Welcome back to part 5 of this 5-part series on function compositions, the classwork. So this is number 16 on the classwork, and I was hoping I could help a lot of people out with this. So when you're doing function compositions, what you want to do is you want to take one of the functions and put it inside the other function. So for this one, we want to find g of f, right? G of f of x. And what that means is I'm trying to figure out what g of f of x is. And then once I figure that out, I'm going to state what its domain is going to be. But before I get to that, I just want to figure out what the function is going to be. So I'm taking the function f of x and I'm placing it inside of the function g of x. So what's that going to look like? Well, I start off with g and I go to f of x. So I know that f of x is going to be equal to the square root of x minus 5. So I'm going to put that inside this set of parentheses right here. Square root of x minus 5. And then after that, I'm going to close it up. What this means is I'm taking the function g of x now, and I'm evaluating it at the square root of x minus 5. And what that basically means is everywhere you see an x in g, I'm going to replace that x with a square root of x minus 5. So way up here in the function g of x, this x has to be replaced with the square root of x minus 5. So basically, I'm taking the whole function f of x and I'm placing it inside of g of x. That's what I'm doing. So right here where it says x squared, I'm going to replace that x with a square root of x minus 5. But everything else about the function is going to stay the same. I'm still going to be squaring whatever this is, and I'm still going to be adding 5 at the end, right? That's what the function g of x tells me. But I have to replace this x right here with the square root of x minus 5. So let me change to red, and let me put a square root in here. Still getting used to drawing those. Okay, so now I have a square root, but I also have a square, right? So these two symbols are actually going to cancel each other out. So whatever's on the inside the square root is just going to come out, which is going to be x minus 5. But remember, I still have a plus 5 at the end, so I do need to bring that down to my answer. So now I have x minus 5 plus 5. What happens there is the negative 5 is going to cancel out with the positive 5 to give me 0. So that's why these two numbers cancel out. And I'm just left with x. So it turns out these functions are inverses of each other. So we figured out what g of f of x is. That's going to be x. But I still have to state its domain, right? So what's the domain? Like, what's the definition of domain? Domain is just going to be the set of all x values. The set of all x values. So when you look at this function, which x values can be its inputs? Which x values can I put in to get y values? Well, I can put in all real numbers, right? That's what you would think. But actually, when you're doing a domain of a composite function, you really need to look at the function on the inside first. Because what you're doing with a composition is you're taking a domain, let's call it x, and you're mapping it to a range, which is going to be the set y. So the function f is going to take x to y. But there's also a function g that comes after that that's going to take y to a new range. Let's call it z. So g is going to be a function from y to z. So when you look at the domain of a composite function, you have to look at what x values can you put into the first function, which is square root of x minus 5. So what's the domain of f of x? What is the domain of f of x, where f of x is equal to the square root of x minus 5? So which x values can you put in this function? Well, you got to make sure that you're taking the square root of 0 or positive numbers, right? You can't take the square root of a negative number and expect to get a real answer. So what you're going to do is you're going to take the inside of this and you're going to set it greater than or equal to 0. So I'm going to take that x minus 5, set it greater than or equal to 0, and I'm going to solve for x. So for this inequality, I can add 5 to both sides. And when I do that, the minus 5 and the positive 5 cancel out on the left side, leaving me with just x greater than or equal to 0 plus 5, which is just going to be 5. So this is going to be the domain. In other words, when you're looking at the function f of x, which is equal to the square root of x minus 5, which x values can you actually put in that function? Only numbers that are greater than or equal to 0. Only numbers that are greater than or equal to 5. Because if you choose numbers that are less than 5, like 4, you're going to have 4 minus 5 on the inside right here, which is negative 1, and you can't take the square root of negative numbers. So the domain is going to be x greater than or equal to 5. And that's the domain of a composite function. I hope that helps.